All right, so for slope fields, you know that I like to draw a chart. So I have x values. I tend to put them on the left here. And my x values, if I'm looking up at the graph there, are just 0 and 2. And then my y values appear to be 0, 1, and 2. Okay. So remember, you're just going to take these values. So for example, here I'm plotting the point, or I'm looking at the point, I should say, 0, 0. And I'm going to put that into my dy dx, my differential equation. So I'm going to put a 0 in for y, a 0 in for x. And why don't you take a minute and fill out that chart so you can pause me. So I have 0, -1, -4, +4, +1, and 0. And now all you're going to do is you're going to put your little slashy things on your graphs, on your graph. Singular, one graph. There we go. So there's my zeros. Now I have a -1 and a +1, so they should look kind of the same but in opposite directions, same steepness, I mean. And then at the two y values, those are going to be even steeper, one positive, one negative. So roughly, that's what your picture should look like for part A. All right, so y equals f of x is the particular solution for the given differential equation. And we have an initial condition of f of 2 equals 3. So right there, we have a point 2, 3. And we want to write an equation for the tangent to this graph. Think about line tangent. What are we supposed to be thinking? So we're supposed to be thinking y minus y1 equals m times x minus x1. All right, well, we already have our x and our y, x1 and y1, so I'm going to do y minus 3 equals m times x minus 2. So the only thing I'm missing is the slope, but aren't I lucky? I have the slope up here. So I'm just going to take that slope, dy dx, and I'm going to evaluate that at the point 2, 3. So my y value is 3 and my x value is 2. Why don't you pause me and figure that out? So you're going to have 9 over 1, which is 9. So then y minus 3 equals 9 times x minus 2. All right, so let's read the question again. So it says write an equation for the line tangent to the graph of y equals f of x at x equals 2. So we just did that. However, they are also asking us to use that equation to approximate f of 2.1. So y is approximately 9 times 2.1 minus 2, and then I'm going to add that 3 over. Why don't you pause me and figure that out? And the answer is y is approximately 3.9. Okay, so last part says to find the particular solution. Remember, particular solution means we are going to cross multiply. And we are going to separate variables, get y by itself, so on and so on. All right, so if I cross multiply, I end up with dy times x minus 1 equals y squared times dx. Now, what's our next step? Our next step is to get our variables, our like variables, together. So I am going to divide by y squared. That way my y's will be on the left. And I'm also going to divide by x minus 1. That way my x's will be on the right. So that leaves me with dy over y squared. I'm going to make that y to the -2nd dy. It's equivalent. And over here I have dx over x minus 1. All right, so what are we going to have to do on the left-hand side? Is pretty easy. It's just basic integration, right? Because that is going to be my next step. I'm going to have to integrate both sides. But how am I going to integrate that right side? And I hope you are saying u substitution. So what's your u? Your u is x minus 1. And then your du is just 1 dx. So on the left-hand side here, I'm going to have negative y to the negative first power equals, and then on the right-hand side, I have du over u, which when I take its integral is the ln of u, which is x minus 1. And then don't forget that we have to put plus c. Okay? All right, well, I have an initial condition, and that is that f of 2 is 3, so I know that point is 2, comma 3 that I'm going to plug in. At the same time, I am going to change this to just negative 1 over y, if that's all good with you. So my y value is 3, so that's going to be negative 1 over 3, right, equals the ln of, now 2 minus 1 is 1. Now technically, we do have these guys in absolute value, parentheses, but the ln of 1 is just 1. And what do we know? I'm sorry. Let me rephrase what I just said. The ln when I plug in 2 is just 1, so that's why I'm writing just a 1 there. And what is the ln of 1? 0, right? So then right here we know that negative 1/3 is equal to c. Okay, so let's go back and plug that in. So I have negative 1 over y equals the ln of x minus 1, and then that's going to be minus 1/3. Okay, so I'm going to start by getting rid of, because I'm trying to get y by itself, right? So I'm going to start by taking this negative and distributing it over here, which will turn this into a positive 1/3 and this into a negative ln. So that's going to give me 1 over y is equal to, and I'm just going to flip those around. So 1/3 minus the ln of x minus 1. You don't have to, but okay. Lastly, though, the issue that I have here is that y is not by itself yet. It's still a fraction. So I'm going to flip this. So I'm going to take the reciprocal of this and watch what I'm going to do over here. We don't have to think too much. It's nothing crazy. I'm just going to try to squeeze it in here. Sorry. So I'm going to get y equals, so I'm taking its reciprocal. So what I'm going to do is I'm going to take that 1/3 minus the ln of x minus 1, and I'm just going to put it over 1. See, that's taking the reciprocal, and that will be our final answer.